In this video, I'm going to outline a very specific and intelligent method for prefix to prefix conversion. In fact, I would like you to stay with me till the end of the video for better understanding. I am going to divide this video into two parts: conceptual learning and problem solving. It is very important to understand the concept, the definition of this concept, and outline everything related to this concept before going to the problem solving part. When you go to the problem solving part, you will then have even a better understanding for the concept. So you can go back, read the definitions again, and you will see that you are linking between the concept and the problem solving technique in a better way. So let us start. The word pre in English means before. Prefix. A prefix is a word, letter, or number that is placed before another word or letter or a number. And the unit prefix indicates multiples, tens, hundreds, thousands, or fractions. 1 over 10, 1 over 100, 1 over 1000 of the unit, of the base unit. These are the prefixes that I'm going to use in my examples. With my method, you can use any type of prefixes, but I will just concentrate on these ones. The famous ones are like deci, centi, milli, macro, nano, or deka, hector, kilo, and mega. Any of these prefixes can be used with the SI system unit or with any other unit, and the method will be general for all problems. Before we go to the problem solving, I would like to make sure about one thing. Probably you already know about it, but let me activate your memory so that understanding this point is crucial to understand my method of solving prefix to prefix conversion problems. Now, when you say 1 kg, actually you are pronouncing three things here: the number 1, the other number kilo, 1000, and the base unit, the symbol G. When you say 300 micrometer, you are actually talking about three things: the 300 multiplied by 10 to the power minus 6 multiplied by the meter, and that is equal to 300 multiplied by 10 to the power minus 6 meter. When you say 3.2 milliliter, I am sure many people, when they see the word milliliter, they think it is just one word. No, it is not one word. These are two words. One is a number, and the second one is a unit, a base unit. So we have 3.2 multiplied by 10 to the power minus 3, which is the milli, and then multiplied by the liter. Okay, so when you see 1 kg, when you see the kg, you will think that it is only one word, a kilogram. That is not one word. These are two words, 1000 and a gram. And when you say milliliter, these are two words, milli, 10 to the power minus 3, and the liter. So gram, meter, liter, these are symbols. These are symbols. We don't substitute them with anything else. They stay gram. The gram G still stays G. The meter stays M. The liter stays L. But we can substitute the kilo and the micro and the milli by their numbers. Now, let us start with the first example. 3 kg equal to how many in decigrams? 3 kilograms equal to how many decigrams? Bear with me and look at the question very clearly. you will see that we have three components on the left hand side: the 3, the kilo, the thousand, and then the G. On the right hand side is a number that we want to solve for, a deci, 10 to the power minus 1, and the gram. On the left hand side we have two numbers, 3 and k, 3000. And then on the right hand side we have the number that we want to solve for and dc, 10 to the power minus 1. This is what we have on the left hand side and the right hand side. And if we substitute by numbers, then we'll have 3 multiplied by 1000. And on the right hand side, we have the dc, 10 to the power minus 1. Don't worry about the gram on the left hand side and the gram on the right hand side. These are symbols. These are base units. These are not numbers. We care about the numbers. So we have 3000 on the left hand side and we have 10 to the power minus 1 on the right hand side multiplied by a number. So now it's very easy and you can see what would be that number if you multiply by 10 to the power minus 1 equal to 3000. So that's 3000 over 10 to the power minus 1, that is 30,000, and the problem is solved. So the answer is 30,000. 3 kilograms equal to 30,000 decigrams. How many centimeters are there in 18.2 nanometers? In another way, 18.2 nanometers equal to how many centimeters? Again, on the left hand side, we have the 18.2 multiplied by the nano multiplied by the meter equal to the number in question multiplied by the centi multiplied by the meter. Substituting with numbers, 18.2 multiplied by 10 to the power minus 9 on the left hand side and 10 to the power minus 2 for the centimeter on the right hand side. And all what you need to do now is what is the number that if you multiply with 10 to the power minus 2 will equal to the number on the left hand side. So that is equal to 18.2 over multiplied by 10 to the power minus 9 over 10 to the power minus 2, and that is 18.2 multiplied by 10 to the power minus 7. So that is the answer, 18.2 multiplied by 10 to the power minus 7. I haven't seen this method in the other YouTube videos there. Have you seen this method there? Did you know about this method before? Do you think it is an easy one, a difficult one? Can you apply it? These are examples of base units. Units like gram, meter, second, liter, ampere, joule, and pascal. These are the units that we don't substitute by a number. These are definitions. We use prefixes with these units. So whenever you have these units, like G for gram or M for meter, it stays as a symbol. We don't change or substitute by a number. So we can say milliliter, microampere, megajoule, kilopascal, milliseconds, kilogram. So we use the prefixes with these base units. Whenever you see these base units, they remain symbols. There will be letters before and letters after. On the left hand side, you will have some prefixes, which are numbers with these base units, which will be equal to a number with the base unit. All what you need to do is equalize between the number on the left hand side with the number on the right hand side. Keep the base units same, untouched. Just equalize with the numbers to solve the problem. Another example, this time about units of area. 1 kilometer squared equal to how many meter squared? Now, we're going to use exactly the same way. Either we have one-dimensional units, two-dimensional units, or three-dimensional units. We are going to solve these examples exactly the same way. So 1 kilometer squared means 1 multiplied by a kilometer multiplied by a kilometer. That what does kilometer squared mean? And the squared is on the kilometer. okay, on both of them, the kilo and the meter. So this is the left hand side. The right hand side is the number in question multiplied by a meter multiplied by a meter. I'll not worry about the meters on the left hand side and the meters on the right hand side. So the numbers will be 1 multiplied by 1,000 multiplied by 1,000 equal to the question, and so it is 10 to the power minus 10 to the power 6. That's it, done. So 1 kilometer squared is 10 to the power 6 meter squared. A question about volume. How many decimeters cubed are there in 44.5 centimeter cubed? In another way, 44.5 centimeter cubed equal to how many decimeter cubed? Again, um, the same thing, same way, same method. In here, we are just going to multiply 3 times because we have the cubic power. So it's 44.5 multiplied by centimeter, multiplied by centimeter, multiplied by centimeter. Bear in mind that the cube is on the centimeter, not on the 45, not on the 44.5. Okay, so 44.5 multiplied by C multiplied by C multiplied by C. As I said, don't worry about the meter. It doesn't have any value. Equal to the number in question multiplied by DC meter, DC multiplied by a DC multiplied by a DC. Substituting with numbers, this is what we get. And then after that, it is actually 44.5 multiplied by minus 6 equal to the number in question multiplied by 10 to the power minus 3, which gives you at the end the value 44.5 multiplied by 10 to the power minus 3. So the answer now is that 44.5 centimeters cubed is actually equal to 44.5 multiplied by 10 to the power minus 3 decimeter cubed. Did you see the method? Can you engage with me in the comment and let me know about this method? Is it a good method? Is it an easy one? What do you think about it? Have you seen it before? Please let me know and engage with me by commenting. And we came to an end. Thank you very much. If you are still here until now, I would like you first to thank you. And second is, would you please go down and like the video, subscribe to my channel, ring the bell notification button and choose 100 so that you get all my videos in future. And another thing, would you please share this video with the classmates so that they also get the benefit if you think you already got benefit from this video. Thank you very much and see you in another video.